Welcome to Cholesky's method. We are studying numerical analysis, and in the last lecture we studied Crout's method to solve the system of linear equations. Cholesky method can be thought of a sister method of Crout's method. It is also used to solve system of linear equations, but with a technique slightly different from the technique we studied for Crout's method. Right. For Cholesky's method, these are four simple steps that we studied. These are very similar to the steps that we studied for Crout's method in our last lecture. The steps are, first of all, given a linear equation, we convert into Ax is equal to b like we normally do. The square matrix, a vector is a vector. Then we decompose A into L times L transpose. In the Crout's method, we decomposed A into L times U, the lower matrix and the upper matrix. Here we have only one matrix L, and the other matrix, in place of U, instead of U, we have the transpose of that matrix L. And we find, with this equation, we find L and LT. LT means L sub L superscript T means the transpose of the matrix L, the lower matrix. Right. If we plug these values in here, if we plug this L times L transpose here in this equation, this becomes L times L transpose times x is equal to b. And if we suppose this L transpose x to be equal to y, this equation becomes L times y is equal to b. And since we have supposed L times x to be equal to another variable y, we can write it like this. So in this equation we would have computed this L in step number 2. So in step number 3 we have L available and B available from step number 1. So we can straight away find y. And if we look at this equation, the last equation, we have L transpose computed in step number 2. So by the time we reach step number 4, we have L transpose. And we also have y computed in the last step, step number 3. So we can straight away find x, the unknown. Right. So this is how we proceed using these four simple steps. Right. Let's understand this method with the help of an example. I've written here a very simple example in which we have only three variables, x1, x2 and x3, and we'll go through these four simple steps to find the values of vector x, x1, x2 and x3. So let's start and perform step number 1 first. For step number 1, we have Ax is equal to b. So A is the coefficient matrix 1, 1, 1, 1, minus 1, 1, 1, 1, 2. Then x1, x2, x3, and this matrix of the values on the right hand side of these three equations written in the form of a matrix B. Right. So now let's move on to step number 2, where A is assumed to be equal to L times L transpose, like this, where L is the lower matrix in which we have non-zero numbers in the lower triangle and all other numbers are 0. And this L transpose is the transpose of this matrix computed by converting rows into columns. So the first row is 0, 0, convert it into, write it as the first column in the transpose matrix. The second row is 0, 0, written as the second column. The third row, DEF, written as the third column. That's all. That is the transpose. So A is now L times L transpose. Let's multiply these two matrices, L and transpose of L. Right, it's A times A squared. We know how to multiply two matrices. The first row is first multiplied with first column, then first row with second column, then first row with third column. So first row with the first column, A squared plus 0 plus 0. So this is A squared. Then first row, the second column, AB plus 0C plus 0, 0. So 0. AD plus 0E, 0, 0. 0 times E is 0 plus 0F is 0. BA written as AB plus C0, C times 0 plus 0 times 0. B times B, B squared plus C times C, C squared plus 0 times 0, 0. So this is how we can proceed, and we can go on with this multiplication unless we get this matrix, this beautiful matrix where we have A, B, C, D, E and F. So now we have to equate these values so that we can find the numbers A, B, C, D, E and F, and then we will be able to perform, after we get all these numbers A, B, C, D, E and F, we will be able to get L and the transpose of L, and then we will be in a position to perform step number 3 and step number 4. Right, so since these two matrices are equal, they both are 3 by 3, this means the elements at the corresponding positions are also equal. This means 1 is A squared. A squared is a 1. So this means A is plus minus 1. Right, AB is a 1. AB is also a 1, leading us to the fact that B is also plus minus 1. So these are some simple things. We can compute A times D is 1. Since A times D is a 1, this means D is also plus minus 1. Then AB is a 1. We know A, we know B, so let's neglect this. B squared plus C squared is minus 1. B squared plus C squared is minus 1. B squared would be, B is plus minus 1 is squared would be a 1. 1 plus C squared is minus 1. This means C squared is minus 2, or C would be J square root of 2. This is minus 2 square root is minus 2 square root is minus 1 times 2 square root is minus 1 square root times 2 square root. Square root of minus 1 is a j or iota square root of 2. Right. So we can proceed further to find D. BD plus CE is BD plus CA is a 1. Right, so BD plus CE is a 1. So B is plus minus 1, D is plus minus 1. Multiplying these two will result 1. Plus CE, C is J square root of 2 times E is a 1. Right, so let's walk here. So J square root of 2 times E is 1 minus 1 is a 0, leading to E is equal to 0. And the last thing is F. So neglect this because we already know A and D, we already know B, D, C and E. So this D squared plus E squared plus F squared can be written equal to 2. So let's see, D squared plus E squared plus F squared is written equal to 2. D is plus minus 1, E squared is 1 in any case, E is a 0, E squared is also a 0, plus F squared is a 2. So F squared is 2 minus 1 is a 1. So this means F is also plus minus 1. Right. So now we can write A, L and L transpose matrices here. It's A is 0, 0. We can work with positive and negative values, but let's work with positive values first. A is 1. B and C. B is 1 and C is J square root of 2. D is 1. E is a 0 and F is a 1. Right. And this is of course the transpose of this matrix. 1 0 0 1 J square root of 2 0 1 0 1. Right. So now we have completed step number 2, and now we're ready to perform step number 3, the second last step, in which we are going to find y the arbitrary vector, and then we use that vector y to find x in the last step. So let's move on to step number 3, where we find ly. We write ly is equal to b and find y. Ly is equal to b. Ly is equal to b. B is 3, 1, 4. 3, 1, 4. Y is the unknown vector, y1, y2, y3, where L is this matrix 1, 0, 0, 1j square root of 2, 0, 1, 1. Right, so now we multiply these matrices. 1 times y1 is y1 plus 0 is equal to 3. So we straight away get the first component, y1. 1 times y is y1 plus j times under square root of 2 times y2 plus 0 times y3. 0 times y3 is a 0, is equal to a 1. y1 is 3. So y2 is 1 minus 3 is minus 2 with this j square root of 2 divided by j square root of 2. Right, this 2 in the numerator can be written as square root of 2 times square root of 2. So this cancels with this, and we know that 1 over j is a minus j. 1 over j is a minus j. We studied in complex numbers. So y2 is 1 over j is minus j. There is another minus. Minus times minus becomes plus. So this becomes plus j square root of 2. Right. So we have computed y1, y2, and the last step is to compute y3. This becomes y1 plus 0 plus y3 is equal to a 4. Since y1 is a 3 plus y3 is 4, this means y3 is of 1. So now we have computed y, and now we are ready to perform the last step, step number 4. This one, L transpose x is equal to y. Right, so y is y1, y2, y3. y1 is 3, y2 is j square root of 2, and y3 is a 1. And we know L transpose, this is step number 4. It needs L transpose, and we already have this matrix L transpose. This one is L transpose. So we have to find x using these expressions. Using this expression, L transpose x is equal to y. So L transpose is 1, 1, 1, 0 j square root of 2, 0, 0, 0, 1. X, our unknown, x1, x2, x3, and y is 3 just 2 times 1. Right, so next we want to multiply this x1 plus x2 plus x3. This is equal to 3. So we cannot find anything from here because there's one equation, 3 variables. Let's try the other one. 0 times x1 is 0, j times 2 square root of 2 times x2 plus 0 times x3 is 0 is j square root of 2. This means x2 is 1. Right. and the third equation is 0 0 x3. X3 is 1, right? So now we have x2, we have x3. Plugging these values x2 and x3 here, we'll get x1 plus x2 plus x3 is equal to 3. X1 is 1. So the final unknown x is x1, x2 and x3, and they're all 1s. Great. Right. So the last optional step is you know that step is verification of your answer. They're going to verify whether these values are correct, whether they satisfy these three equations, and if they do, this means this answer is correct. Right, so let's plug these values in. 1 plus 1 plus 1 is 3. That is right hand side, so it satisfies the first equation. Let's see whether this x vector satisfies the second equation. 1 minus 1 plus 1 is 1. That is equal to the right hand side of the second equation. And x1, 1 plus 1 plus 2 times x3 is 2 is 4, and it is equal to the right hand side. This means we have reached to the correct answer. That's all for this lecture. We'll keep on studying more about numerical methods in the upcoming lectures. Thank you.